Far beneath the surface of the Earth, every 24-karat gold bar begins as ordinary rock. These vast pits are carved layer by layer, following geological structures that hold microscopic particles of gold. Drilling rigs bore precise patterns of holes into the rock, preparing the ground for controlled blasting. Each blast is engineered to fracture the ore without wasting energy or damaging the valuable rock. When the sequence fires, thousands of tons of gold-bearing rock are broken free in just a few seconds. As the dust settles, heavy machinery moves in to begin the next stage of the journey. Giant excavators tear into the broken ore, loading it bucket by bucket for transport. Each scoop drops several tons of rock into haul trucks designed to carry extreme loads. From here, every loaded truck becomes a moving link in a carefully timed production chain. Convoys of trucks climb out of the pit, carrying ore from the mine toward the refinery. Seen from above, the roads look like spirals carved into the earth, guiding each load to the surface. As they exit the pit, the ore leaves the world of blasting and excavation, heading toward advanced processing.
On long-haul roads, the trucks shuttle continuously between the mine and the refinery complex.
Each journey brings another 100 tons of ore closer to the refining stages. Even at this stage, the gold is invisible, locked inside tiny grains of rock. Ahead lies the processing plant, where that hidden gold will finally begin to be separated from waste rock. From this point on, every step is carefully monitored, measured, and recorded. Ore is stockpiled and blended to keep the feed to the plant consistent, balancing grades and quality before crushing begins. Trucks empty their loads onto coarse stockpiles, creating a buffer between the mine and the crushers. From these piles, feeders draw ore at a controlled rate onto conveyors that lead to the primary crushing circuit. Conveyor belts connect each stage, turning the refinery into one continuous production line.
The first major step inside the plant is primary crushing, where enormous machines break the rock down to manageable size.
Ore is fed into large hoppers that channel it toward powerful jaw crushers below.
Here, the rock finally enters the refining line, beginning its transformation from ore into pure gold.
In the next stage, towering crushers will reduce these fragments step by step, preparing them for grinding and chemical separation. The primary jaw crusher uses immense pressure to break large chunks of ore into smaller, more manageable pieces. Between hardened steel plates, the rock is squeezed and fractured, reducing its size in a single, powerful motion. Vibrating feeders and grizzlies separate finer material and control the flow of ore into the crusher. From here, crushed ore moves by conveyor to secondary and tertiary crushers for further size reduction. Screening stations sort material by size, sending oversized rock back through additional crushers. Vibrating screens separate fine and coarse fractions, ensuring the right size distribution for downstream grinding.
Cone crushers provide another stage of crushing, squeezing rock between a rotating cone and a fixed outer shell.
By this point, the ore has been reduced to a size suitable for grinding into a fine powder. Transfer towers link the crushing stages with the grinding circuit, keeping material moving without interruption.
Fine ore stockpiles act as a buffer, keeping the grinding mills supplied even if other equipment stops briefly.
From these stockpiles, ore is metered onto conveyors that feed the grinding mills at a controlled rate. Inside, towering grinding mills turn the crushed rock into a fine slurry.
As the mill rotates, the charge of steel balls and ore rises and then cascades, grinding the rock through impact and abrasion.
Water is added to create a slurry, allowing the finely ground ore to flow to the next stage. Powerful pumps move this slurry through a network of pipes, pushing it toward classification and separation circuits.
Hydrocyclones separate fine particles from coarse ones, sending coarse material back to the mill and fine slurry onward.
The finest fraction, rich in gold-bearing minerals, flows toward the chemical processing tanks.
Together, the mills, pumps, and cyclones form a tightly controlled circuit, constantly adjusting to maintain the right particle size.
From grinding, the slurry enters massive leach tanks, where chemistry begins to release gold from the minerals. Agitators keep the slurry in motion, ensuring every particle contacts the solution for maximum recovery.
Carefully metered reagents are added through a network of pipes and valves, tightly controlling the leaching conditions.
Control rooms monitor every stage, from crushing to leaching, adjusting flows, speeds, and levels in real time. Digital systems track tonnage, particle size, and slurry density, helping keep the process stable and efficient.
With the ore finely ground and in slurry form, the plant is ready to extract gold through carefully controlled chemical reactions.
Here, chemistry begins to pull gold out of the finely ground slurry. Agitators keep every particle in contact with the leaching solution. Speed, mixing, and chemistry are all precisely controlled.
Dedicated dosing skids feed each chemical at exactly the right rate.
Leached slurry overflows to the next stage of separation. Thickeners concentrate the slurry, separating solids from clear solution. Slow-moving rakes guide heavy particles toward the center underflow. Cleaner solution flows over the rim and is collected for further treatment. Dense underflow from the thickener carries concentrated gold-bearing solids. This stage reduces water volume and prepares the slurry for filtration. Filter presses turn thickened slurry into nearly dry concentrate cakes. Under high pressure, liquid is forced through filter cloth, while solids are trapped. Filtered solution is collected separately for further refining. When the press opens, solid cakes of gold-rich concentrate are revealed. These cakes contain far more gold than the original ore. Concentrate is conveyed toward drying and smelting areas. Drying reduces moisture, improving efficiency in the furnaces.
The dried concentrate is now ready to be blended for smelting.
Operators add flux materials that will help separate metal from impurities in the furnace. This blend travels directly to the high-temperature smelting furnaces. Smelting furnaces are the heart of the metal refining section. Blended concentrate is carefully charged into the furnace through enclosed chutes. Inside, temperatures climb high enough to melt metal and separate slag. Ladles are preheated, so molten metal will not cool too quickly during transfer. The next step will reveal the first molten form of gold-bearing metal. Inside the furnace, gold-bearing metal forms a glowing molten bath. Impurities rise to the surface as slag and are carefully skimmed away. Once ready, the molten metal is tapped into preheated ladles. Overhead cranes move each ladle safely to the pouring area. This first pour creates doray bars, semi-pure metal that still contains silver and base metals. As they cool, the doray ingots turn from glowing liquid into solid metal bars. Their surfaces are rough, but they hold most of the gold recovered so far.
Doray bars are then transferred to advanced refining circuits.
Overhead cranes move each ladle safely to the pouring area.
Here, electro-refining uses electricity to separate gold from other metals.
Gold dissolves from one plate and deposits in purer form on another. Each batch is weighed and recorded before casting begins. In induction furnaces, the refined gold is melted one final time.
Now the metal is nearly pure 24-karat gold.
Molten 24-karat gold is poured into precision molds for investment-grade bars. As the metal cools, solid bars slowly take shape. Freshly cast gold bars are removed from their molds for finishing. Polishing machines give each bar a smooth, mirror-like surface. Hydraulic presses stamp the refinery mark, purity, and unique serial number. Every bar is weighed to conform its exact mass.
Inspectors, 2 Caucasian women, review rows of bars, checking markings, finish, and documentation.
Finished bars are sealed in protective packaging for secure transport. The most valuable bars are stored in heavily secured vaults. Here, pure 24-karat gold waits as a reserve of lasting value. From hidden ore to shining bars, this is the complete journey of gold.
If you enjoy factory and gold refining videos, don't forget to subscribe for more.